It is located in Elimu. I want to trust that your day has been amazing. Today we are going to look at the learning area, mathematics, especially grade 8, and to be specific, we are going to talk about circles. We're going to talk about circles, and that is, we are going to look at two things today. Number one, we are going to look at the arc length of a sector, and also we are going to look at the perimeter of a sector. Now, these two factors are one of the components of circumference of a circle. So they all come as a result of circumference of a circle. So we are going to look at the arc length and perimeter as a result of circumference of a circle. So we are going to start. So at the end of the lesson, as a student, you're supposed to know how to find the arc length of a sector and also the perimeter of a sector. Now, let's start right away with the arc length of a sector. Arc length of a sector. Let's start right away with the arc length of a sector. So, in the arc length of a sector, basically, we will be able to know, the types of a sector. We will be able to know the type of a sector, and I want you students to note that we have two types of sectors. We have two types of sectors. Number one, we have a minor sector, and we also have a major sector. Now, how do you differentiate the two? A minor sector is formed. A minor sector is formed from an angle less than 180 degrees. The minor sector is formed as a result of the angle less than 180 degrees. And we have a major sector. So you can give a good guess that the major sector is found as a result of an angle bigger than, an angle greater than 180 degrees. So we are talking of angle like 190 to 30. So you can mention several examples. So tumesema, we have said that we have two types of sectors, minor sector and the major sector. Now, a sector, so to define a sector is simply a portion from a full circle. Is simply a portion of a circle. So for a sector to be formed, there must be what we call angle theta, and this is simply the angle that has been subtended by the sector to the center of the circle. So one of the components of a sector, we have an angle, and that angle is the one that is subtended by this whole sector to the center of the circle. And usually it is denoted by theta. It is denoted by theta. Number two, a sector is also formed by two radius. We have the first radius and we have the second radius. And we know that radius, it is the distance from the center of the circle to the circumference of the circle. So this sector is bounded by two radii, one and the second one. So together they form two radii. Number 3, a sector is also formed by what we call an arc length. Arc length. This is simply the curved part of a sector. It is simply from here, for example, from here to here. So let's name this A, let's name this B, and let's name this C. So from here to here, we have what we call an arc. And because it is an arc from a minor sector, so we can also call this arc AB as a minor arc. It can be called a minor arc because it is formed from a minor sector. Now, can you look at arc ACB? That is also another arc, and it can be called a major arc simply because it is an arc that is formed from a major sector. So, boys and girls, those are the major components, those are the components of a sector. And we have said that a sector is made of an arc length. It is also made with a radius, and remember the radius are 2, and then we have angle theta, and that angle is subtended by the arc to the center of the circle. So after that brief introduction, so the first thing that we are going to look at is the arc length. How do we calculate this arc length? How do we calculate this arc length? So this is the time where a good student takes a book and a pen and writes down, because these are notes worth writing down. So we are going straight to what we call an arc length of a sector. Arc length of a sector. And I'll start by a simulation that we have said that an arc is formed, a sector is just a portion it's just but a portion of a circle. Now, we have said it is formed by 2 radius, and we have an angled theta that is subtended by the sector to the center of the circle. So we have an angle, we have 2 radius, and we have an arc length. And I want you to note that arc length is denoted by a small l. It is denoted by a small l. So in mathematics, arc length is denoted by a small l, and then we have r for radius and theta for the angle that has been subtended by the arc or the sector to the center of the circle. So how do we find an arc length? How was the formula derived? Now, I want you to note that when we are working the arc length of a sector, we are simply finding the distance of the curved part of that particular sector, and it is coming out of the whole circle. It is coming out of the whole circle. So we have learned previously in our other strands and other, in the lower grades, that we know how to calculate the circumference of a circle. So today we are not looking at circumference of a circle, we are just looking the portion of a circumference of a circle. Now the formula now becomes, because we have angle theta, so it is angle theta, and that angle theta, it is gotten from the whole circle. And we know that angle inside a circle add up to 360 degrees. We know that angle inside a circle add up to 360 degrees. And now, because we are simply finding the arc length of a sector, so we can take theta out of the whole sum of the angles inside a circle, which is 360 degrees. 360 degrees. And then we multiply it by 2 pi r. 2 pi r. We multiply it by 2 pi r. As of now, I'm sure you understand what theta stands for, what 360 stands for, what 2 pi r stands for. So if you are a good student, as of now, we know where theta is the angle subtended. It is the angle subtended at the center of the circle, and 360 degrees sum of the angles in a circle. We also have 2 pi r. So 2 pi r is the circumference of the whole circle. The circumference of the whole circle, and then radius equals to, the radius equals r stands for the radius, and the r stands for the radius. So that is basically how you calculate the arc length. You simply take theta over 360, you multiply by 2 pi r. And I have said that 2 pi r stands for the circumference. So you're simply finding just a portion of the circumference of the circle. So we are simply finding a portion of the circumference of the circle. So class, this can be shown well by several examples. So we are going to do a couple of examples just to demonstrate how you can find an arc length given an angle and the radius. So let's go straight to examples. To answer example 1. Let's start with example 1. So I hope the producer is going to project example 1. I hope producer is projecting example 1. So example 1, as it has been projected. Example 1, so calculate. So you have been told to calculate the arc length of a sector. Arc length of a sector given an angle of 6. So the angle, so you are told to calculate the arc length given an angle of 60 degrees, and then you have been given the radius of, 14 centimeters. So we are going to calculate the arc length given that the angle subtended at the center of the circle is 60 degrees and the radius is 14 centimeters. So what you do, remember we have said before, as we have learned before. So the first thing, solution. So we know, as of now, we know that arc length equals to theta over 360 degrees, and you multiply it by 2 pi r. So you have been given theta, which is 60. You have been given the radius, which is 14 centimeters. So let's substitute. Where we have theta, we are substituting with 60. So we have 60 degrees over 360 degrees multiplied by 2, and then we are multiplying by pi. Remember, pi in most of the cases is represented by 22 over 7 or 3.142. So the place where we have pi, we are simply going to replace with the 22 over 7. So by 22 over 7, and then by The radius. So the radius, if you see clearly, we have been given the radius as 14 centimeters. So this is now what we're going to multiply by. So we have just substituted our contents in our formula theta over 360 times 2 pi r. So the next thing, take out your calculator and start by cancelling, the better. If you are not good at cancelling, start by multiplying the numerator part of the fraction, and then the denominator, and then you come and divide. So take your, so we are going, so 7 can cancel with 14. So 7 into 7, 1. 7 into 14, 2. Now, these 2 can be cancelled to 360. So 2 into 14, 2 into 2, 1. 2 into 360, 180 degrees. 60 and 180. So let's cancel 0 with 0. 6 here, 1, 6 here. 6 into 18, so it goes 3 times. So if you look keenly, the numerator part and the denominator part cannot cancel out anymore. So what do you do? So you multiply the numerator part, which is 1 by 2 by 22 by 1. So 1 by 2, we get 2. 2 by 22, we get 44. So you're going to take 44 divided by 3. 44 divided by 3. So when you do your sum, you will be getting what we call, so 3 into 44, how many times? 3 here, 1. 3 into 44, 1. So that 1 remains and makes this number to be 14. 3 into 14, how many times? 3 into 14, so it goes 4 times and remains 1 over 3. So the answer now becomes 14 and 1 over 3 degrees. Remember, this one can also be expressed as a decimal, but you can also express it as a fraction. So the arc length, remember we are working with the arc length, and the units here are in centimeters. This one being a length, 14.5 centimeters. 14.5 centimeters. So, boys and girls, when it comes to the working of arc length, it is very simple. You just substitute whatever content you've been given you just substitute it to the given formula, and then at the end of the day you are going to work it correctly. So let's do another example, example 2. I hope you've written this. So let's do another example, example 2. Example 2. So let's look at example 2. So the example 2 reads as follows. Calculate the arc length. Calculate the arc length of an arc if the radius of an arc is 8 centimeters. So again, so example 2. You have been given the following contents. You have been told that the arc length, you are supposed to calculate the arc length given the radius given the radius as 8 centimeters, and you have also been given the angle theta as 40 degrees. You have been given angle theta as 40 degrees. So solution, as I have said, you just substitute the contents that you've been given by the question to the formula. And we know that the formula of an arc length, which is represented by L, equals to theta. So So equals to theta over 360 degrees. You multiply it by 2 pi r. Do you have the theta? Yes, we have it. Do you have the radius? Yes, we have the radius as 8 centimeters. We know that pi, we can use pi as 22 over 7 or 3.142. So let's substitute our contents. So we have 22 over 7 as pi. So when substituting, so you take theta to the same as that theta is 40 degrees. So the place of theta we substitute by 40 degrees and divide with the 360 degrees and multiply it by 2, and then the place of pi we are writing 22 over 7, and also the place of r, we've been given r here as 8 centimeters. So r is 8 centimeters. So as usual, so the next thing that you have been left with is to cancel out, or you multiply the numerator components and then the components of the denominator, and then you later on divide. So in this case, we have 2 and 360 using the divisibility test, that we say a number is divisible by 2 if the last digits are 0 or even number. So if you look here, this one is a 0, this one is a 2. So it means it can be divisible by 2. So 2 here, 1, 2 into 360, 180 degrees. So 0 cancels 0. So 2 here, 2 here, 2 into 18. How many times? 9 times. So after so we multiply the top constituents. The top constituents, which are 2 by 22 by 8. So it is 2 by 22 by 8 divided by 9 by 7. So let's multiply the top one. This is 44. 2 by 22 we get 44. 44 by 8, 32, carry 3, 32 plus 3, that is 352. So the top constituents gives us 352, and then 9 by 7 you get 63. So after you divide, you are going to get 5.582. 582 centimeters. So you are always expected to write your answer into 4 significant figures. I believe those examples can guide you to the working of the arc length of a sector. Now, there is one important thing that I also want to talk today. This question, arc length of a sector, sometimes examiner can twist them. They give you the radius, they deny to give you the angle that has been subtended at the center of the circle, and they end up giving you the arc length. So it is your duty to find the angle that has been subtended at the center of the circle. So I have said, not all the time they'll ask you to find the arc length. They can give you the arc length. For example, like in the case below, they give you the arc length, they deny you the angle, and they give you the radius. And then they ask you to find the angle subtended at the center of the circle by the given sector or arc. So I want you to note that when we are talking of an arc, we are simply looking at the curved part. Like for example, in this example, so the radius here is 8 centimeters. And the angle that we've been given is 40 degrees. So we are simply using these components to find this curved part of a sector. So it is worth noting that. So let's do another example, the last example under that bit, so that we can see how these examiners can also come to, test you without either the angle or the radius, but you've been given the arc length. So write this example down. So this one is an application question. So number 1. So the question reads: a wiper of a bus makes an arc length of 88 centimeters. So you have been told that in this situation, you have been given the arc length. So in the other situation, we've been finding the arc length. But in this situation, we are finding what? So we have been given the arc length first as 88 centimeters. So the arc length is 88 centimeters. Then we are told, so a wiper of a bus makes an arc length of 88 centimeters on the windscreen. It subtends an angle of 120 degrees. So subtends an angle of 120 degrees. So you are told to find the length of the wiper. So in short, they are telling you to find the radius. So you have not been given the radius of that wiper's windscreen. So the radius we don't have. But we also know that pi is given by 22/7. So in this situation, you have been given the arc length. You have been given the angle subtended at the center of the circle. And we know that pi, in most of the cases, is equivalent to 22/7. So what are we going to do? So let's make a sketch so that we see what exactly this question means. So let's assume that this one. So let's assume this wiper is of this shape, made as it was wiping the windscreen. It made a shape that looks like a sector, and we have not been given the radius here. So we are supposed to work out the radius, and we've been given the theta as 120 degrees. So 120 degrees is the angle subtended at the center of the circle. And then we have been told the arc length is 88. So from here to here is 88 centimeters. So it is your work now to find the radius. Again, solution. Again, so we know that arc length is given by angle theta, which is over 360 degrees. You multiply by 2 pi r. So this is the arc length. So where in the place where we have the arc length, we substitute with 88 centimeters. So the arc length is given by 88 centimeters, and the theta, in the place of theta, we've been given 120 degrees. So in the place of theta, so we replace by 120 degrees over 360 degrees times 2 times 22/7 times radius. So the radius we've not been given. It is the one that we are supposed to work it out. So let's try and simplify so that we can get a more simplified equation. Now, we have formed an equation and we want to simplify it. So let's start. 0 cancels 0. 12 to 12, 1. 12 to 36, how many times? 3. So do we have any other component that can be simplified further? No. So we have 88. So we multiply the top constituents. 1 by 2. 1 by 2 we get a 2. 2 by 22 we get 44 by r. So we get 44 r over 3 by 7. 3 by 7 gives you 21. Now, we are supposed to find r. And in order to remain with r, or to make r the subject of this equation, so we are going to multiply by the reciprocal of 44 over 21, which gives us, so r equals to, so we multiply both sides by 21 over 44 times 21 over 44. So as you multiply both sides, 21 cancels 21, 44 cancels 44. So at the end of the day, you're going to find out that r equals to 88, which is this one, times the reciprocal of 44 over 21, which is 21 over 44. Which is 21 over 44. Now, can this be cancelled out? The answer is yes. 44 and 88. So 44 goes to 88 twice. So the radius of that sector now becomes 2 multiplied by 21, where you get 42. And because it is also the length, so the units now become centimeters. So the radius of this circle, we have now found that the radius of the circle now is 42 centimeters. So it is as simple as that. Provided you have the constituents, and those constituents you are supposed to just fill them, substitute, so that you see which constituent you do not have, and that is that now what exactly you're supposed to find. So like in this case, we had been given the arc length, the angle, but we did not have the radius, and we had a pi. So we just substituted, and we ended up getting the radius as 42 centimeters. So whatever the question will come like, please make sure you do it. Provided you know the formula, just substitute every constituent to the given formula. So that is how you find the arc length of a sector. That is how you find the arc length of a sector. So it's also, in some books, they also refer to it as the, finding the length of the arc. So the meaning is the same. So we are done with the first part of our lesson today of finding the arc length of a sector. So the second part of our lesson today is finding the perimeter of the sector. Now the difference between the two, I have said when we were working the arc length, we were only focusing on the curved part of that sector. But in the next bit, we are only going to look at all the distance around that sector. And the only new thing that is arising from the perimeter is that we are going to add this radius and this radius to this arc length. So that is the only new thing that we are going to add. From the definition of perimeter, that perimeter is the distance all around the figure. Now, we are supposed to find the distance of the sector. Now, when finding the distance of the sector, we are going to add the radius, and then these are the radius, and then the arc length. So let's go to the part number 2 of our lesson today. Part number 2 of our lesson today. So let's go and look at the sector of the circle. Perimeter of a sector. Perimeter of a sector. Now, where do we start from? We start from now, the definition. So we have known that perimeter since from grade 5. That perimeter is simply the distance that is covering a given figure. the distance covered by a given figure. Now, because we are talking of a sector, my pen is not working at all. So we are going to see the distance from here to here, then to here. So we know that this distance is called the radius. This other distance is now the radius, and this is the arc length. So we're going to find the distance, this arc length, we add to this radius, and then we add to this radius. So this is what exactly the formula that we are going to come up with. We are going to come up with now perimeter, which is given by P, equals to this arc length, or rather the length of the arc, which we said that it is denoted by L, and we add it to this R plus R. R plus R. So we add it, so we take the arc length, and then so it will give you something that looks like L, so L plus 2R. Now, previously, in the previous subtopic, we have looked at the value of L, and we said this arc length, it is the curved part of a sector. So the arc length, now we know the formula for finding the arc length. That arc length is given by theta over 360 degrees multiplied by 2 pi r. Right? So we have substituted L, which is the arc length, with the formula which is theta over 360 times 2 pi r. And then we are going to add it to 2r. We are going to add it to 2r. So theta over 360 multiplied by 2 pi r by 2 pi r. This is the formula for working out the arc length. And then 2r, now 2r is this radius and this radius. So let me indicate it so that we can all see. So we have said that for us to work out the perimeter, and remember here we also have an angle theta. So we have said for you to work the perimeter, and I have said that the perimeter is just the distance all around the figure. So we are going to find the arc length. So perimeter equals to the arc length plus r, this r, plus another r, this r. So r plus r gives you, so perimeter P equals to L plus 2r. And previously tumesema that this L, which is the arc length, is given by the formula theta over 360 degrees multiplied by 2 pi r. Then we add 2r. So this is now the formula for working out the perimeter. Arc length plus 2r. So this can be best demonstrated by an example. It can be best demonstrated by an example. So example number one. So I hope it is projected. So number one, find the perimeter of a sector. Find the perimeter of a sector. So you are told to find the perimeter of a sector given that the radius, R stands for the radius, given that the radius is 7 centimeters, and the angle subtended at the center of the circle is 120 degrees. and the angle subtended at the center of the circle is 120 degrees. So you are told to find the perimeter. So you've been given the radius, you've been given the angle. So we know that for you to work out perimeter, you're supposed to work out the arc length, which is defined by 360 multiplied by 2 pi r. This is now the arc length. And then we add the arc length to 2 radii. So in short, this is what exactly this statement is trying to mean. And then this one is the radius. So you are told now to find the distance that is covering from here to here to here. So this radius is the same here, 7 centimeters. So you'll have to calculate the arc length, and then you add to 7 and then 7. So let's substitute our contents. So we know that P equals to theta. So what is the value of theta? It is 120. So you take 120 degrees, you divide it by 360 degrees, and then multiply by 2 and pi. I have always said that pi, it is given by 22/7, or it can be given by 3.142, but the best version is 22/7. So 120/3 times 2, so the value of pi now is 22/7, and the value of radius, the radius is 7. So we have just substituted, and then plus, so this one is added to the 2r, 2 times. So the value of r is 7. So the value of r is 7 centimeters. So you work out to the arc length first. So 120 here 1, 120 here 3. 7, cancel 7, so that the constituents now are 2. So are 44/3. So 2 by 22 gives you 44. Divide by 3 by 1 gives you 3. So this one, you add it to 2r. 2 by 7 gives you 14. Gives you 14. So divide 44/3. Take your calculator and divide 44/3. So you'll get, so 3 into 44. So 3 into 4, 1. So that 3 by 1 gives you a 3. So it means 4 minus 3, you remain with 1. So 1 and 4 together forms a number 14. So how many times does 3 go to 14? So it goes 4 times. So that 3 by 4 gives you a 12. So 3 by 4 gives you a 12. So it remains 2/3. So it is 14, and 2/3, you add it to 14. So when you add this together, you get 28 and 2/3 centimeters. So the perimeter is simply one of the lengths. So the units will remain to be centimeters. So boys and girls, that is a good example for working out the perimeter. Again, I have said that you can be given a question that you have not been given the angle, or you have not been given the radius, but you've been given the arc length. So it is upon you to start, you start by writing the formula and then fill in the constituents, so that you can be able to do what? You can be able to get the answer. So as I have said before, so let me summarize the lesson. Let me summarize the lesson of today, and I am going to summarize. So for both the perimeter of a sector and the length, the length of the arc, they kind of look like the same, but the difference is, so summary. So the summary. So perimeter, we have said that you work perimeter by theta over 360 degrees plus 2 pi r plus 2r. And then the arc length, just take theta over 360 plus 2 pi r. Thank you so much. That has been my time. Thank you for watching, and have a blessed evening.